Hey Math Marvels, let's look at multiplying polynomials and really look at FOIL versus array. A lot of people love to use FOIL because it's easy to remember. Pretty much let's write down what FOIL means. It just means the first terms, the outer terms, the inner terms, and the last terms. So when I think of multiplying these two binomials, literally it's like, how do I multiply the first set of numbers, the first set of terms, so 2x times 9x. Then the outer terms, the ones that are on the outsides, are the next set, so it'll be 2x times 4. Then you're going to go into the inner numbers, 5 times 9x, and then you go and do the last numbers, 5 times 4. And so this is what I see people doing a lot of times. It's easy to remember and they just multiply. All right, multiply 2 times 9 is 18, x times x is x squared, 2x times 4 is just 8x, 45x, and 20. And then you just look to see, do I have any like terms? You do, right over here. So you're going to add these guys up and you're going to get 53x. So you end up with 18x squared plus 53x plus 20. And so a lot of math teachers in Algebra 1 use this. And it's just helping kids remember how they're going to multiply. Oh, first terms, outer terms, inner terms, last terms. And it's a nice organized way. But here's another way that can help, because sometimes people can think linearly from first step to last step. I like to also think visually and spatially. So I'm going to create an array. It's just a rectangle. And if you use a lot of lattice multiplication, this will make a lot of sense to you. And all I'm going to do is put the same terms in here. So let's make that look like 5. I can make that look like 5. 9x plus 4. And this is plus 5. And I'm just going to multiply the numbers inside the boxes. So I'm going to do the product of these two numbers in here, the products of these two numbers in here. So same thing, 2 times 9 is 18, and then x squared. In this box, 2x times 4 is 8x. Here is 45x, and here is 20. And the other thing I kind of like about this is you can clearly kind of see where your like terms are. They'll be literally right here. And since they're both positive, I can add them up, and I still get 18x squared plus 53x plus 20, because these are our like terms. Okay, so same method, same answers. It doesn't really matter. When you have a binomial times a binomial, doesn't really matter. Here's where it does matter. What if I have a binomial times a trinomial? Now I can't use FOIL because I'll miss numbers. So I could do the first set of numbers, so 2x times 9x, and then do the outers, and then do the inners, and then do the last. But at no point did I do anything multiplying this 3x. I miss it. In this work, nothing ever gets multiplied by it. So just take a look. So here I was doing 2x times 9x squared. My outers will be 2x times 2. My inners, 5 times 9x squared. And my last number is 5 times 2. But I'm missing the 3. 3x isn't getting multiplied by anything. So FOIL doesn't really work as a structure when you have anything other than a binomial times a binomial. FOIL only works when you have two terms in the first expression and two terms in the other one. You're multiplying it. But array will work. All I do is make a bigger array. Let's give ourselves some space. And I'm still putting the terms here. Just so you see it's positive, and I just multiply them out. So 18 x to the third, 45 x squared, 6x squared, 15x, 4x, and 10. So the big thing with arrays is you just have to know where the two numbers are coming from. And the great thing is when it's time to add up, I can see where my like terms are. I can see them. I can see them when I'm adding them up. So now with the first one I have 18x to the third power plus 45 plus 6, since they're both positive, would be 51 x squared plus 19x, because 15 plus 4 is 19, plus 10. So boom, I can get the answer here. If I had done it with just FOIL, I would have gotten some of the terms, like I would have gotten the first one. Here's 4x, here's 45x squared, here's 10. And I definitely have the 10, but I'm missing some of my middle terms because I missed it. Okay, so does FOIL versus array matter? Doesn't matter when you have a binomial times a binomial. Absolutely matter when you have anything else. Okay, so that's it for now, Math Marvels. I will see you in the next one. Be well. And if you have more examples of math problems or math ideas that you want to see, hit me up in the comments, ask questions. I love making videos. I want to make this the best year ever for everyone. Have a great day. Bye.